Geometry Common Core, Regents Review Video 1. In this video, we're going to cover the topics of parallelogram properties and a couple of random triangle stuff too. Centroids, some proportions, exterior angle theorem. So let's dive into parallelogram properties. First, we want to talk about angle properties. What type of angle properties are present in parallelograms? I think one that people remember most is opposite angles congruent. So that would be like, for example, angle A is congruent to angle C. Angles opposite in a parallelogram are congruent. If I were writing this in a proof, I would write a little more detail, and I would probably say, the angles, or opposite angles of a parallelogram are congruent, kind of thing. The other, and so that's for A and C, but also works for B and D. The one that we don't talk about as often is adjacent angles supplementary. And so that would be like angle A plus angle B equals 180. This angle and this angle together add to 180. That doesn't come up often in proofs, but it could come up algebraically, like if I say this is x plus 5 and this is 2x, and I want you to find the measure of angle, So like that does come up on the algebra side of problems, but not much in the proof side. That's pretty much it for the angle properties of the core parallelogram. Side properties, again, the most notable would be opposite sides. Well, I guess there's really two. Opposite sides congruent and opposite sides parallel. The opposite sides congruent, opposite sides parallel, both are used in proofs where you would say opposite sides of a parallelogram are congruent to say, two things are congruent, like AB congruent to CD, AB congruent to CD, or in a proof, you can say AB is parallel to CD. The parallel may come involved where if you wanted to prove, say, alternate interior angles, that type of thing. I'll get to the diagonals in a minute. So we could also say AB is parallel to CD because opposite sides are parallel. As far as algebraic proofs go, it's not too much, but if I said, like x plus 5 is this and 2x minus 1, well, you can set them equal to each other because opposite sides are equal. And then diagonal properties. So let me draw in the diagonals first. You should draw them in too. And let's mark a point in here. Let's call this point E, where they're crossing. And so the diagonal properties, first of all, they do create alternate interior angles because of the opposite sides parallel. But the major diagonal property of a parallelogram is that the diagonals bisect each other. They bisect each other, meaning that they're line bisectors. Like, for example, E is the midpoint of AC. That's kind of what we're saying, that they cut each other in half. So AC is being cut in half, and what you get from that is AE is congruent to EC. Diagonals are bisecting each other. And the same thing for BD. Now, BD is cut in half, but it's going to be a different measure than AC is. The diagonals are not congruent in the parallelogram. Now, the diagonals bisect each other, but they do not bisect the angles. This angle is not being bisected. The diagonal is not an angle bisector. It's only a line bisector. They're all only bisecting each other. That's important. When we get down to the rectangle and the rhombus, we'll see a lot more stuff come out from that. But the one diagonal property for the parallelograms is they bisect each other. And how do you prove a parallelogram? There's 4 ways to prove a parallelogram. It's both let me say both pairs, actually. Let me erase this. So both pairs of opposite sides congruent. That's one. Both pairs of opposite sides. Sorry, let me get rid of that box. Both pairs of opposite sides. Come on, go away, little box. Both pairs of opposite sides parallel. So, in this case, it would be, if I prove, this is congruent to this and this is congruent to this, that would prove it's a parallelogram. Or if I prove this is parallel to this and this is parallel to this, that would prove it's a parallelogram. But it's got to be both pairs congruent, both pairs parallel, or you could do a single pair. It could be a single pair of opposite sides. But if you're doing a single pair of opposite sides, it's got to be the same single pair. Let me add that. Same single pair of opposite sides, congruent and parallel. And that's always the trap. So if I'm saying these are congruent, it's got to be they are also parallel. That proves a parallelogram. So I don't have to do anything with the other pair of opposite sides. But what does not work is saying these are congruent and these are parallel does not prove a parallelogram. So it's got to be, if you're doing congruent and parallel, it's got to be the same pair of opposite sides. And then the last one is if you prove that the diagonals bisect each other. All right, so how about down to the rectangle and rhombus? What's the difference here? For rectangle versus rhombus, what I always like to, tell my students is remember that for each of them, first of all, they are parallelograms. All this stuff still applies. They're special parallelograms. But they still have the opposite sides, congruent, parallel, diagonals bisect each other, all that good stuff. But they each have something congruent, something perpendicular, something congruent, something perpendicular. And for the rectangle, what's perpendicular is the sides. So perpendicular sides. For the rhombus, the sides are congruent. All sides are congruent. All four sides congruent, like the square. It's a diamond, a rhombus. So what's perpendicular here for the rectangle is what's congruent for the rhombus. Now, what about the other thing? Well, the other thing involves the diagonals. Again, if you draw in your diagonals, in a rectangle, they're the same length. In a rhombus, they're not, but they're perpendicular. So for the rectangle, you'll have congruent diagonals. For the rhombus, you have perpendicular diagonals. And I think it's really helpful to see the opposite nature of these two shapes. Like what's congruent in one is what's perpendicular in the other. So diagonals congruent, diagonals perpendicular, sides congruent, sides perpendicular. And that's really the key to remembering these things. So they both have right triangles somewhere because they both have something congruent. They both have, a lot of the same properties, just kind of in different places. The one other thing about the rhombus is that the diagonals are also angle bisectors. That's where you see the diagonals are cutting the angles in half. So that's not true for the rectangle. That's only true for the rhombus. And then the square has all this stuff. The square is when you kind of bring all these together. Now the diagonals still bisect each other for all of these shapes because that's the parallelogram property, that they bisect each other. But it's in the rhombus that you first see them bisecting the angles. All right, so that's those properties. Now, some simple triangle stuff real quick. For side proportions, just remember that if these are parallel, that makes similar triangles. And when you're working with similar triangles, the safest proportion is to always think small triangle over large triangle. Like, for example, if I'm going to say that this is... let me use letters. Like this is X, this is Y, this is A, this is B. The proportion people want to make from this a lot of times is, X over Y equals A over B, and this is false. That doesn't work. If we're doing small over large, A over B, that's like the bottom of this small triangle, and B is the bottom of the big triangle. They correspond. So A over B is small over large. And X is the left of this small triangle. Sorry. But the left of the big triangle is this whole thing. You can't do the two pieces here. And this would be the sum X plus Y. So X over X plus Y is how you would have to set up your small over large proportion here. That's just a very, very common trap that people want to do X over Y, A over B. X over Y is something called side splitter, and it actually does work if you're doing this over this, because that's also a side that's being split. But for safety, just focus mostly on small triangle over large triangle, and you can never go wrong with that. The centroid. Remember where the centroid comes from. The centroid comes from the fact that this point L here is a midpoint, which makes something like IL a not a mid segment, I'm sorry, a median. IL is a median because it goes from the, it's super sloppy, sorry, I'm having trouble writing today. Median. If it goes from the angle to a midpoint, it's called a median. And if this is also an angle to a midpoint, where the medians cross is the point called the centroid. So F here is called the centroid. And what it does is it splits your segment into a 2-to-1 ratio. 2-to-1 ratio. So for example, if like I know that this is, a length of 20, then this piece over here is going to be a length of 10. The shorter segment is half the length of the longer segment. They're in a 2-to-1 ratio. And the last thing I wanted to cover real quick for you guys in this video was the exterior angle theorem. And what that says is that the exterior angle of a triangle, like angle NOP, is equal to the sum of two angles in the triangle. It's equal to the sum of the two non-adjacent interior. The sum of the two non-adjacent interior. Now, what do we mean by non-adjacent interior? Well, adjacent, interior is three interior angles. This one over here would be adjacent to it. So we're talking about these other two angles over here. This angle and this angle are interior and they're non-adjacent. So it would be angle N plus angle M. And this is very helpful when they throw expressions in these things. Like if we said, all right, this is 5x, this is 4x plus 2, and out here is 10x minus 10. Find the measure of angle something. Well, what we'd have to do is we'd have to add those two together. So it would be 5x plus 4x plus 2, and that equals the exterior 10x minus 10. So this plus this equals the exterior. Here we got 9x plus 2 equals 10x minus 10. Subtract 9x, add 10, x equals 12, and then I could plug in and find any angle that the problem asks me for. Remember, x usually doesn't end your problem, so you got to plug it back in to find what the question's asking for. Now, a lot of times people say, well, I could find this angle and do supplementary. Yes, but in this particular case, you can't find that angle because there's not an expression there. So you do need to use this sometimes. Sometimes the problems are designed for that. All right, so that's what I wanted to cover in this first review video here. Some parallelogram properties and a couple of random triangle stuff. See ya.